Hi, everybody. Today we're going to talk about scientific notation. Scientific notation is always of the form a number, decimal, and then however many numbers you want after that, and then times 10 to some power. It always has to be in this form if it's in scientific notation. Let's look at a problem. 5.1 times 10 to the seventh power. That is already in scientific notation. It's in the form that I just stated. What you want to do is first notice that we're multiplying by some number that's 10 times 10 times 10 times 10, 7 times. It's going to be a big number. 5.1 is going to get bigger. I start with my value and then I move my decimal point one time for every number. So that's 1, 2, 3, 4, 5, 6, 7. And I put zeros everywhere. There's one of those little things. I'm going to rewrite this, and I have 1, 2, 3, 4, 5, 6 zeros. 51 million is the answer. And that's it. Next one, 2.84 times 10 to the negative 6th power. Remember from exponent week, this is the same as 2.84 times 1 over 10 to the positive 6th. Really what we're doing here is dividing by 10 6 times. This number is going to get smaller. Try not to think of these as right and left. I know that's how most of you were taught. Try to think of it as bigger and smaller. It'll help a lot. This is going to divide. The number is going to get smaller. If the number is going to get smaller, then my decimal is going to go this way because this is how I make it smaller by 10. Smaller by 10 again, or 100. 1, 2, 3, 4, 5, 6. I fill these with zeros, and I put a decimal point on the left end. This becomes 0.12345 284. That's really all there is to that one. If we start with a number 172000000, my decimal point is always at the end. I'm going to move it 1, 2, 3, 4, 5, 6, 7 places. It's going to be 1.72 times 10. And we have to figure out if that's a positive or a negative 7. From this number to this number, it's getting smaller. If this number is smaller, then this number has to compensate to make them equal. When this gets smaller, this gets bigger, and vice versa. If this got bigger, then the other one would get smaller. Well, I'm sure we'll do one like that in a minute. The answer to this is right here. That was A. B, the signal from a certain satellite takes approximately 8.1 times 10 to the minus 2 seconds to reach Earth. Write this number in standard notation. I'm really dividing by 100, 10 times 10. That means my number is going to get smaller. That means my decimal is going to move 2 places to the left. My answer would be 0.081. Now this one's a little different because now we're multiplying 2 numbers in scientific notation times each other. And we're going to use our exponent rules. First thing we're going to do is multiply 3.5 times 2, which gives me 7, times 10 And remember, if you have a base to a power times a base to a different power, the rule was b to the m times b to the n equals b to the m plus n, which is what we have. The bases are the same for 10, and then we just add the exponents, which makes 7 times 10 to the 13th power. Now we have 8 times 10 to the 8th power times 1.5 times 10 to the minus 7. What we're going to do here is we're going to multiply 8 times 1.5. And then we're going to rewrite this as 10 to the 8th times 10 to the minus 7th. I did this on purpose because it'll be easier to multiply these. 8 times 1.5 is going to be 12. Times 10, well, we have an 8 plus minus 7, 10 to the 1. And now it says to write our answer in scientific notation. Since 12 is not in scientific notation, because remember, it's only one number in front of the decimal, I have to make this 1.2, which means I've made this number smaller by 1 decimal place, which means I have to make the 1 bigger by 1. 12 got smaller by 1 decimal place, 10 gets bigger by 1 decimal place. So my final answer is 1.2 times 10 squared. We only have 2 more left. We have 9 times 10 to the 7th divided by 3 times 10 to the 6th. I can say that's the same as 9 divided by 3 times 10 to the 7th divided by 10 to the 6th. 9 divided by 3 is 3. And we have the rule that says b to the m divided by b to the n, we subtract. That means this is 10 to the 7 minus 6, which is 10. And we want to write it in scientific notation. 3 times 10 to the first power. 18 times 10 to the 6th divided by 3.6 times 10 to the 4th. I'm going to separate it into 2 separate fractions just to make it a little easier. 18 divided by 3.6. We never have decimals in the denominator when we divide. To get rid of that decimal in the denominator, I can multiply by 10 over 10, which gives me 180 divided by 36. That's how I'm going to do my division. And I think this goes 5 times, 3318, yes. So 18 divided by 3.6 is equal to 5 times 10, and then we're going to use the same rule because we have division and our bases are the same. 6 minus 4 is 2. That's my answer, 5 times 10 squared. And that's really all there is to scientific notation.